Okay. Now, after introduce the first order linear ODE and the Bernoulli equations, we are trying to make examples how we can solve it analytically. Okay, that is the example for Bernoulli equation solution. Okay, and we have the example is dy over dx equals x squared plus 3y squared divided by 2xy. And we will write as a Bernoulli equation solution. But before doing that, you notice this is actually a homogeneous equations. And when you have the homogeneous equations, you can solve it using the substitution. But here, the purpose we are trying to show how to solve the Bernoulli equations. So we will solve using the from the non-linear equation to the linear part and solve it using the first order linear equation solutions. But you should know that we have different ways to solve such example, okay? So rewrite the equation to Bernoulli form. Okay, what is our Bernoulli form? That is dy prime plus py equals q times y to the nth power. That is our Bernoulli form. So let's write in that form. Y prime, that is minus 3 over 2x y, that equals x divided by 2 y minus 1. Okay, so we know that the p will be equals to minus 3 over 2x, and q is equals to x over 2. Then the a will be equals to minus 1. So we are rewriting these examples into the Bernoulli form to figure out what is our coefficient and what is our order of a. Then we know that this is a Bernoulli equation form. We will solve it from the nonlinear part to the linear part using substitution. So we will substitute using u equals to y to the power of 1 minus a. And our a is minus 1, so our u will be y squared. Okay? Then we will rewrite this. We will rewrite the equations, the nonlinear equations, into the linear equations, but the function will be ux instead of y. Okay? So rewrite the non-linear Bernoulli equation into first order linear ODE of ux. Okay. Okay. So the u prime plus 1 minus a pu equals 1 minus a q. That is our derivative previously. And then we just need to input all the coefficients using this example, which the p and q and a will use here. So that will be u prime plus 1 minus 1 will be 2. The p will be minus 3 over 2x. So it's minus 3 over 2x times u will be equals to 1 minus 1 will be 2. The q will be x divided by 2. So it's x divided by 2. And then you can write u prime minus 3 over x, u equals x. And you can see that we have all the coefficients is either constant or as function of x only. So this is a linear first order ODE of ux. Okay. Then how we solve these equations, right? How we solve it? For solve the first order linear ODE of ux, and we will rewrite this ux, which is u prime minus 3 over x, u equals x. This is the linear ODE we are going to solve. And using u will be e to the minus px dx. The integral of e to the px dx q, integral of dx plus some constant c. And we have our px here will be equals minus 3 over x. Our qx is equals to x. Then using this px, qx, going back to our integral part, we will get our u, okay? So we have the e to the px dx. Let's solve it separately. That is e to the integral minus 3 over x dx, right? And then the minus minus is basically cancel out. That is e to the 3 over x dx. And 3 over x dx is what? Integral. That will be the 3 ln x, right? So that is e to the 3 ln x. And e to the ln x will be x. So this term will be equals to x cubed. And after that, we can integrate this part. So it's e to the px dx q integral dx. And we know that q is x, px is minus 3 over x. So it's e to the minus 3 over x dx times q, which is x here, and integral. And that is e to the integral, this part will be x to the minus 3, right? X to the minus 3 times x dx. That will be x to the minus 2 dx. And what's that? In the end, the integration will be minus 1 over x. Then we can put this 2 term into our original u term, okay? So u will be x to the cube times minus 1 over x plus some constant, right? So our final solution will be minus x squared plus cx cubed. And we also know that our u was using the substitution. U was equals to y to the square to substitute this whole non-linear ODE. So our y in the end will be equals to minus x squared plus cx cubed plus minus. Okay.